Alright, so we've looked at simplifying rational expressions with multiplication and division. Now we're going to look at adding and subtracting. And again, rational expressions are just variable expressions where we use polynomials instead of just numbers. So this is just like adding and subtracting fractions, just with variable expressions. Those tend to be kind of complicated for people until they really get it down. And so, of course, you start throwing variables in here, it's going to be even more complicated. So you have to be very careful about how you're doing your work. So we'll start with just regular fractions and we'll work into more complicated polynomial type expressions. So let's say I wanted to add 5/6 to 7/8 and then subtract off 3/24. So the first thing I need to do in order to work with fractions for adding and subtracting, I need to find the least common denominator, or the lowest common multiple between 6, 8, and 24. And the lowest common multiple between 6, 8, and 24, and again, this isn't the greatest common factor. Don't confuse that. This is what's the smallest thing these numbers go into. What is the smallest multiple of them? So, for example, the multiples of 6 are 6, 12, 18, 24, 30, 36, so on. Multiples of 8, 8, 16, 24, 32, 40, so on. 48, 24, 48, 72, so on, multiples of those. So what's the smallest one of those multiples these have in common? And that is 24. All of these numbers go into 24 evenly. So what we're going to do is we're going to change our first two fractions into equivalent fractions with that denominator. So 5/6 is going to become 20 over 24, 7/8 is going to become 21 24ths, and 3/24 is going to stay 3/24. It's already had the common denominator. And then you're going to add the numerators. Once you get all the denominators to match, that's basically describing the size that you're working with. And then the top is how many of those you have. So when you add, you're adding how many or taking off how many. So 20 plus 21 is 41. 41 minus 3, 38 over 24. And then, like always, we should go ahead and reduce our fraction at the end and get 19/12. So what I want to do here is kind of peek under the hood and see what's really going on in this process of adding and subtracting fractions. So what we're going to look at each of these denominators in their prime factored form and see if we can see some relationships here. So 6 is 6 equals 2 times 3, and that's its prime factors. 8 is 2 times 2 times 2, or 2 to the third power. And then 24, which is also our least common multiple, is 2 to the third times 3. And what we look at here, what we notice, is that 24 has at least 1 2 and a 3, which is what 6 has, is 1 2 and a 3. It also has at least 3 2's, which is what 8 has, at least 3 2's. So 24 is big enough to cover each of the prime factors, or the factoring of the 6 and the 8. And what we want to do now is ask ourselves, what is each of those missing? So, for example, 6 was missing. It had a 2 and a 3, but if I look at my least common multiple, 24, I should have 3 2's. So it's missing 2 2's, or 4, from it. 6 times 4 is 24. What is the 8 missing? Well, 8 has the 3 2's, but it doesn't have the 3. So it's missing a 3. And that's going to tell us what we need to multiply each of those by to change to those equivalent fractions. So if we take 5/6 times 4 over 4, and again, 4 divided by 4 is really just 1. It's just another version of 1. What that's going to give us, we're going to multiply by what our denominator is missing to make 24, top and bottom, and that gives us our 20 over 24. And we did the same thing with the 7/8. We said what was the bottom missing? It was missing 3. So we multiplied top and bottom by 3, and that gave us our 21 over 24. And then we added those fractions together, we subtracted, we got 38 over 24. Now, how did we reduce that down to 19/12? And again, just a reminder, like we talked on the last video, is you're going to break those down so that you have a factor, or multiplier, in common. So 38 is 2 times 19, 24 is 2 times 12. Those 2's cancel out, leaving you 19 over 12. And again, when we say cancel out, we mean they go to 1. So 1 over 1 times 19 and 12. So that's what's going on, is when you're making a common denominator, what you're looking at is to have all the factors that are needed for all the denominators. And you're going to look at what factors is each one missing to find that common factor. And then at the end, you may have to do some canceling of factors that are in common between the numerator and the denominator. So kind of look at a more complicated example. Let's look at this one. So now we're throwing letters in there. I want to first, again, I'm just going to look at this and say, what's the least common denominator? And you might think, well, 5 and 3, the least common denominator is going to be 15. It's the smallest multiple they both have in common. What about those x's and y's? Well, the reason why 15 is the least common multiple is between 5 and 3 is because they don't have anything in common. So you multiply them together when we say they're relatively prime. In this case, they're both actually prime, but they're relatively prime to each other. They don't have anything in common. So 5 and 3, 15, well, x and y we assume don't have anything in common either, so they're relatively prime. So this is going to be 15xy. So we need to have enough in there that'll cover the 5 and the x. It also has to cover the 3 and the y. And so the easiest way to find that is just multiply those together. The thing is, we'd like to find the least. So sometimes if they have an overlap, like 6 and 8 had an overlap of 2, we didn't want to go with 48. That wasn't the least. So we went with 24, which was the smallest multiple they have in common. So what we're going to ask ourselves is, what is each one of these missing? So if you have 5x, you're missing 3y. And if you have 3y, you're missing 5x. So you're going to multiply each of those fractions, top and bottom, by what it's missing. So the first fraction is missing the 3y. So you're going to multiply top and bottom by 3y. The second fraction is missing the 5x. So you're going to multiply top and bottom by the 5x. And so multiplying top times top, bottom times bottom, top times top, bottom times bottom, gives us 6y over 15xy and 20x over 15xy. Now the bottoms match. They're, again, like the size of the fraction. And so what we're going to do is we're going to add those tops together. Now, be aware, 6y and 20x don't actually add together because they're not like terms, but we're just going to say 6y plus 20x. And we're saying we're trying to do that addition, we just can't do it because they're not like terms. And then the last thing you might do is that 6y plus 20x might feel awkward in that order. You might change the order of it around so that the x term comes and then the y term. And you should look to see if there's any common factors between the top and the bottom. And so to look at that, you would have to factor the top. Like, for example, you could factor a 2 out of the top. 2 goes into 20, 2 goes into 6. But is it worth doing that? Because 2 is not going to cancel anything in a 15. So this is our final answer. There's no common factors between the top and the bottom. Remember, factors, not terms. 20x is a term. 6y is a term. But 20x or 6y is not a factor of the top, and you can't cancel it with something on the bottom. Alright, so let's look at an even more complicated problem. So let's look at this. And we're going to start off by asking ourselves, what is the common denominator between x plus 2 and x minus 1? And the answer is, again, these are nothing in common. X plus 2 and x minus 1 are totally different. So the least common denominator is going to be the product of those. X plus 1 times, or x plus 2 times x minus 1. If you have x plus 2, what are you missing? Well, you're missing an x minus 1. You have an x minus 1, what are you missing? You're missing an x plus 2. So I'm going to rewrite this expression a little bit. Instead of saying 5 minus 3, I'm going to say 5 plus negative 3. And then I'm just going to put the bottom in parentheses. So, again, you don't subtract, you really add the opposite. The reason why I do that is going to make it easier to keep the sign straight. Because I don't want to multiply, then worry about changing the signs. I want to change the signs as I multiply. So, again, the first fraction is missing an x minus 1 on the bottom, so multiply top and bottom by x minus 1. The second fraction is missing an x plus 2 on the bottom, multiply top and bottom by x plus 2. Again, what it's missing. And then you're going to just distribute out the top. 5 times x, 5 times negative 1, negative 3 times x, negative 3 times 2, and get 5x minus 5, and negative 3x minus 6. And now the denominators match. So we can just combine the top, and we're just going to combine like terms. 5x minus 3x, negative 5 minus 6. So 5x minus 3x is 2x, negative 5 and negative 6 make negative 11. And again, we would ask ourselves, is there something I could factor out of the top that would cancel out the bottom? And the answer is no. The top doesn't even factor. But even if it could factor, again, what we're concerned about is canceling out something out of the bottom. That's one of the reasons why you see me, I'm not distributing out the bottom, in these problems is because I want to know what the factors of the bottom are so that I can maybe cancel a factor that's combined on the top if I run into one of those. Alright, so let's go to even more complicated problem. So let's say we have this. So first thing I need to do is, again, find the least common denominator. And the least common denominator is going to have every factor that shows up at the bottom. So notice x plus 5, that can't be broken down any further. But x squared plus 8x plus 15 can be. So the first thing I want to do is look at the denominators and factor all of those as much as I can. And so if I factor that first denominator, I get x plus 5 times x plus 3. Well, hey, x plus 5, that matches. So they have something in common. So I don't want to multiply them together to find the least common denominator. What I want to do is make it so they both match. So since the second one already has an x plus 5, all I need to do is multiply it by an x plus 3. And again, to kind of help myself with the signs, I'm going to say, well, I'm subtracting 2x minus 3. Well, that's the same as adding negative 2x plus 3. So I'm going to change both of those signs. So this becomes an addition here. And now what I'm going to do is I'm going to multiply that second fraction by what the denominator is missing, x plus 3 on the top and bottom. Notice I don't have to multiply the first fraction by anything. It already has both of those factors in it. So it's ready to go. I just have to multiply the second one. So I want to multiply these and I'm going to add the tops. So I'm going to kind of do that in one step and just put this all over one fraction now that I got the denominators to match, and I'm going to distribute out that second numerator. So negative 2x times x, negative 2x times 3, 3 times x, 3 times 3. I'm going to get this, combine like terms, x squared minus 2x is negative x squared, 4x, negative 6x, positive 3x is negative 7x, and negative 19, and positive 9, and negative 10. Then, what I'm going to do is I need to factor the top, if possible. And it does look like this might be able to factor, but again, it's a negative x squared, so maybe I want to factor out that negative there so that I don't have to deal with that first term being negative. And then you factor the top, x squared plus 7x plus 10. What are the factors of 10 that add and give you 7? Well, 5 and 3, or 5 and 2. And so x plus 5, x plus 2, and then I'm going to see what matches. Both the top and the bottom have an x plus 5 in common. Those cancel out, leaving you, don't forget the negative that's out front. That's going to leave you a negative x plus 2 over x plus 3. And you notice I leave the parentheses around things just to be safe with the signs. I don't want to, if you put that negative sign up a little higher, it would look like it was a negative x. But you'd have to say negative x minus 2. You'd have to change both of those signs, just like I did at the beginning of this problem. I changed both of the signs in the numerator. So if you don't want to mess with that, you just leave that x plus 2 in a parenthesis, and probably leave the x plus 3 in a parenthesis just to be safe in that case. And then don't forget that negative in front. So that's how you add and subtract fractions. I would watch these videos again, over and over again. Just make sure you understand you're finding the least common denominator, which is going to have all the factors from the bottom. You're going to multiply each fraction by what it's missing, not what it has, but what it's missing on the top and bottom, and then you're going to combine the tops, and then in some cases you're going to see about factoring the top and canceling out a common factor.